Okay, so let's go back to that screen. Okay, so the question is, how do you determine if your Hadoop instance is working properly? So first, let's check. So I am inside my VM right now. Let's just say I newly logged on. First, how do I know that Hadoop is running? So the first thing you check is you can, there are many ways of doing that. The most common way is use the process or PS function. So PS space dash EF will show you all running processes in a Linux system. Not very friendly. There's lots of stuff in the screen. Most of the things in the screen you probably don't recognize, right? And unless you took an operating systems class, a lot of it will be alien. So the next best thing is to run a command called JPS, right? So JPS will just tell you what are the running Java processes. So JPS is short for Java PS. Now, in your instances right now, it's possible JPS is not installed. Therefore, to install JPS, you have to check if you have a package called Java devel, right? So let's do a quick check for the system. So RPM is the Red Hat package manager, which is used to manage software. -Q means query. A means all. Then let's check if it has Java package. So then grep, of course, just returns stuff with Java in front. So in my case, I have this installed, and that is why I have JPS. If you don't have this installed, you will not have JPS. So let's just pretend it's not installed. So I'll uninstall it just to show that it's not installed. Oops, you have to be root to install and uninstall stuff. Oops. So if I run JPS, it doesn't work. Just regular Java, of course, works, right? So then when I do my RPM to look for it, it's not there, right? So in order to install that, you can actually do an RPM yum install Java 1.8 OpenJDK-devel. Now, 1.8 is the latest stable version. There are newer versions, of course, right? But this one is the latest stable version. And just for your reference for this class, a lot of the software in this class, like Hadoop, Hive, etc., depend on Java 1.8, right? So this is how you install Java 1.8. This is so Java 1.8-devel is what you call the SDK to make sure that's installed. Now, this is assuming it wasn't installed, but you were supposed to have done this as part of the Cassandra install, but let's just assume we're doing it again. So when you type JPS now, it exists. Then, of course, the next step is I will edit my bash RC, right? So there's a Java home here. It has to be like this. Now, how do I know what to put in Java home? Actually, that depends on what distribution you are using. So for this case and for the classes case, all Java stuff is placed here, right? So you can either make the shortcut user lib jvm java or user lib jvm java -1.8.0. It doesn't actually really matter. So let's just say I edit it. So whatever value it is, or if there was no value, so let's just say this had no value here and I just make it Java. Okay. Then to make sure that that takes effect, I can log out and log in, or I can do a dot. This is a dot here. You might not see it. Space, then the script file. So it forces me to run the script file. And if I do an echo Java home, then there's Java there, right? So that's to set your Java on. So first thing to do is you check if it's running. Right? So clearly it's not running because there's no stuff there. So to run, go to the Hadoop sbin directory. Start all is the fastest way to run stuff. Okay, so run the start-all command, and this basically runs your Hadoop installation. Now, please take note, this may take a while. Just as a note, so Hadoop, this will start all the Hadoop components. So your name nodes, your data nodes, your secondary name nodes, your task tracker, and your job tracker. Now, since we are running it in sudo distributed mode, everything is simply running on one machine, right? So in this case, this particular VM. Now, for those of you who are, I did recommend you use 4 gig of RAM as your VM size for this class. So if it's not set to that yet, and it was set to 2 gig, you might want to increase it to 4 as we run more stuff inside the machine. But actually 2 is fine, it's just slower. So now after running stuff, let's just say I forgot, right? I left it running and I'm not sure if it's running. So again, you can do again ps minus ef. You can see that Java stuff is running, but you don't know exactly what is running, right? These things here are probably Hadoop, but you're not sure, right? Now, the other way is run JPS, and it will actually name it. So it knows, so it's telling me, oh, there's a data node running, resource manager running, secondary name node running, name node, node manager running, and a name node running, which is great because these name node, secondary name node, and data node are required to run HDFS, and your resource manager and your node manager are your job tracker, task tracker in Yarn. So these are the Yarn versions of job tracker and task tracker, so you know they are working. Now, another way to test if it's working is, of course, run a Hadoop command. So the easiest Hadoop commands are what we call the file system commands, Hadoop fs, ls, for example, to see if your Hadoop file system is running. So this one tells you that Hadoop is running. Now, let me load another window. All right. So where are the log files? Now, the log files by default are inside the home directory of the respective application. So in this case, Hadoop, there's logs, and these are the log files. So you notice each of the daemons running, going back to the first window, so JPS, these are the stuff that's running. There is a corresponding log file. So data node has a log file, name node has a log file. The ones with the dot number are the older versions. So let's take a look at what is inside. So for example, the secondary name node out file. So the out file will tell you, oops, what was run and if there was a problem. So for example, in this case, this ran secondary name node and was trying to run, oops, safe node will be turned off automatically once threshold has been reached. So this means it set my Hadoop cluster to safe mode, right? Because I did not reach the number of blocks reported. Now, this one is usually due to corruption. And I found out that the major reason for corruption in VMs is because we set our VMs to, for example, use 8 gig, diba, when we installed it. But if our underlying file system runs out of space before we hit the 8 gig, which is what happened in my case, and happens actually in I think some of you have encountered this problem. What happens is Hadoop HDFS gets confused because the file system reports it as 8 gig, but in reality, it stopped to write. In my case, it reached 6.3 gig, it stopped writing. So that is a challenge when you're using virtualization, because the underlying file system is dynamic and your host operating system ran out of space. So in this case, I will occasionally see this error here. Now, you're asking me, how come hindi naman siya nag-error when I did the Hadoop fsls command, right? So that didn't encounter an error. So let's see the log file. So the best way to look at a log file is to use the tail command kasi medyo mahaba yung log file. So tail will show you the last few entries. So these are the last few entries. If you put tail minus F, it actually continues to run. So let's look at something more interesting. Let's say name node. Okay, so my Hadoop cluster is in safe mode now. So technically, I shouldn't be able to do certain things. But by running fsls, nag-work na naman siya. So let's try something more active. Let's put a file. I have file here. And because I'm in safe mode, this may encounter an error. See, cannot create because I'm in safe mode, right? So it says here. So you'll see the logs. IPC handler failed, cannot create file, which is exactly the error you're seeing here. right? But this one has the more detailed version. Now, in this case, there's really nothing we can do to fix the safe mode because, I mean, short of me reinstalling the VM, which I don't want to do, I will just disable safe mode and allow writing. So you can actually force disable safe mode. So how do you do that? So there's HDFS, DFS admin is the tool. Say, well, DFS admin has a lot of stuff. So let me show you what's inside HDFS DFS admin first. So this is the administrative command line tool for HDFS. So the HDFS portion of your Hadoop. So you can see report to show you how the cluster is doing, right? So that's one of the commands that you can type. So here it tells me that, oh, I have a cluster that's in safe mode, right? So you try to run Hive or anything like that, doesn't work. I have a configured capacity of 6.19 present capacity, etc. So my utilization is very low because I really don't have stuff in it. Replication blocks, erasure blocks, there's really nothing in it. It has only one live node. And because I configured it one live node for one extra replication, that's fine, right? And the last reported time was just right now. And the number of blocks are 4. So I only have 4 blocks worth of stuff there. Now, again, there's nothing we can do to fix this per se because this is a virtualization problem. This is not really a Hadoop problem. So we can, let's just tell it to ignore the safe mode by disabling safe mode. So leave safe mode. So this is how you force Hadoop to leave safe mode. And when you print the report again, it should say it's off safe mode. Right? Safe mode is off. I think that's right. So there's no safe mode. There used to be a mess. The previous one, notice safe mode is on. This one just has no message about safe mode at all. Right? It describes the cluster, etc. So let's test it if it works. And all the while, in my other screen, I can see what's happening, right? So this is actually the log. So it will tell you more or less. Now, it'll take a while for you to familiarize yourselves on what the log entries mean. And for the purposes of this class, it's actually not necessary at all. But this one can help you troubleshoot in case you really want to get an on-prem version working. Next is, let's test. Okay, Hadoop LS. Okay, my name node and data node is still running. Now let's try to put that file. So this should work now, right? Let's look at the logs and see. See, complete file is closed by DFS client, right? So it's not complete, but it wrote the file. And do an FSLS. File should be there. Cat ring c.c. All right. So now I see the contents of that file. Okay, then I can delete the file. It's another, so if it's a read-only transaction, safe mode allows you to do read-only transactions. So ls, cat will work, but put, rm, cp will not work, right? So since I'm off safe mode, these commands should now be working. Okay? Tapos, ano pa ba? I think that's it, right? So most of the time, those are the most common errors in Hadoop. And in our case, since we're using a virtual machine with an underlying host operating system that may run out of resources, that's why we hit these file system problems. So Hadoop prevents you from writing to a file system that is inconsistent because the amount of space it thought it had and the amount of space you gave it is not the same. And that one will not be fixed because it really is not the same in this particular case. But in a production system, your node is dedicated to Hadoop. So the file size that you allocate to it will be permanent for it. Okay? Did that answer the question? All right. So the best way to tell that Hadoop is working is, of course, the HDFS part and the let's just say the MapReduce portion. So of course you can also test the MapReduce portion, right? So we can naman we can also test that. So the most common commands for testing that would be, you can run the single command line test, right? The, what shall we call this? The grep Hadoop examples thing, right? So you can do that by Hadoop jar. Where is my Hadoop examples? This Hadoop. Comma. No, map produce. There you go. Hadoop examples. Tapos grep input output 3. Yeah, that's another way of testing Hadoop. This one tests naman the map reduce part. Now, so let's just say there's an error here. So this is the stack trace. So I purposely ran a command without putting the files. So there's no input directory and there's no XML files in there. So it will look for the input directory and says input path does not exist. So how do I test that? So Hadoop fsls. Meron bang input folder? Oops, wala. So create ako ng input folder. All right. And I copy my XML files to the input folder. Oops, let's use put so that it assumes this is from local to Hadoop. So put always assumes that this is local and this is Hadoop, so that at least I don't have to specify it. Then let's check if it's there. So my input folder na ba ako? It's the stuff inside the input folder. Yeah, now I can run my example. Well, I didn't have to output 3. Pwede naman output 1. Okay, so it's running. So this is fast because I now gave it 4 gig of RAM, so it should be faster. So there are no errors. So everything should be okay. There should now be an output 3 directory. There's output 3, right? And let me see what the contents of this file is. This is my output. Okay. So again, some basic troubleshooting things now. So when things go bad, you try to break it down. So before you test the task tracker, job tracker part, the yarn part, you test the HDFS part. You can test the HDFS by writing files to and from it. Of course, the basic test is to do the LS first to make sure it's running. Then not, right? The most common problem in our case, it would be in safe mode. You can simply disable safe mode and try it again. Tapos you can also do a check, JPS, to determine what is running. So in order for your Hadoop to run, you have to have these resources. There should be 5 of them. So for the HDFS part, you have to have data node, resource node, and secondary name node. Secondary name node, and data node. For the yarn part, MapReduce part, yarn part, you need resource manager and node manager. Okay, so that's just some basic troubleshooting tips. Again, the reason why I give you 2 options in this class is because for every activity, you actually have the option of running it in, how shall we say this, AWS or in Hadoop. So you're not actually obliged to use Hadoop. Wait a minute. Where did I go? Did I log out? No, I did not. But let me go back to my screen. Okay, see it now? Okay. So quick administrative matters. You now have a Beetle. So thank you for volunteering, right? So I won't have a Beetle, a separate Beetle for grad and undergraduate class. So one na lang for this particular class. So see the Beetle for this class would be Kristen Marie Valle. So thank you for volunteering. Although nandito ba si Kristen ngayon? Wala, right? So she will be the Beetle of this class. Now, if there are any concerns, of course, you can still continue to write to me directly, but it would also be good if you want to coordinate amongst yourselves, you can also coordinate with Kristen, okay? Another administrative matter, I moved the deadline of the second Hive activity to give you more time to adjust to Hive, although the second Hive activity is easier than the first, right? So I think it should not be an issue. The major challenge with the first Hive activity is it's JSON, right? And of course, you have to deal with using Hive for the first time. But once you get the hang of it, it should be okay. The next thing is every succeeding activity, you can actually do it the Apache Hadoop way or the AWS way. So most of the activities here, you can choose which platform to use. I don't normally require you to use one or another unless, for example, there's a performance measure that needs to be done. Then that needs to be done on AWS. The beauty of running it on the cloud version is that you don't have to worry about setting up and troubleshooting. A lot of these troubleshooting things are normally only encountered if you try to install it on-prem. Now, the only difference is, of course, in Hadoop, it's easier to troubleshoot on-prem because it's in your machine. But today, I'm going to show you how to install another tool called HBase, but we will not be doing the step mode execution in AWS. That means it's going to configure a fully working HBase in the traditional way, but AWS will do it for you so that we don't have to do the on-prem version. But I leave instructions for the on-prem version just in case you want to do that as well. Okay, so let us proceed with HBase. So HBase essentially is a database system, right? That is not a traditional database system. So again, we tend to call this NoSQL database system. So the history of HBase is basically started out by Google creating a blob-based system called Bigtable. Bigtable was essentially created to store things, for example, like emails. The thing with emails, for example, is that you and I probably have a lot of emails in common. So for example, yung mga Ateneo announcement emails are with me, are also with you, and also with the other thousands of Ateneo students. The problem with that is if we do the traditional email storage, that means that single email, exactly the same content, would be stored thousands of times, which is a lot of a waste of space. So what Google did is they created a data structure called Bigtable, and they're able to store emails and give it a unique email ID. Therefore, if person 1 and person 2 have the same email, then that email is only stored once. The reason why it's called blob-based, so blob is a computer science database term for it can store any binary data, right? So the thing with emails is it can be HTML email, it can contain attachments, etc. So blob-based systems are perfect for it. So it allowed Google to save space and give you gigabytes of email space as compared to the more traditional email providers, right? And as usual, Yahoo, who did exactly the same thing. So when Google came out with MapReduce, they came out with Hadoop. Yahoo saw that, hey, Bigtable is nice and came out with an implementation called HBase, right? And HBase was used originally by Facebook for Messenger. Because again, emails like messages can get forwarded and there can be copies and copies. Like you send the same picture to many people, there's no point in storing that picture many times, right? So this is Apache HBase. It has now been promoted to a top-level Apache project. Okay, there are many companies that use HBase, and up to today, it's still being used, right? So it's of course Facebook, Pinterest, Netflix, Yahoo, or what's left of Yahoo, Imgur. So anything that has blobs that you give a link to, is perfect for HBase, right? It's not a traditional database with a lot of columns. It's just an ID that points to a large chunk of data. And we have Amadeus here as well. This is a flight booking provider, right? So technical details, number one, it's key value store, right? There's a key that points to some value, and the value is a blob. In the case of HBase, it's column-oriented. So it's a column-oriented database, similar to Cassandra, right? It's transactional, so you can actually do real-time use cases here, unlike traditional HDFS workloads like Hive, for example, or even Hadoop streaming, which are inherently batch by design. It has live APIs so that you can query the database yourself with your applications. It prefers consistency over availability, right? So it is a lot better than your traditional no SQL database that's base, which has eventual consistency as opposed to consistency outright, right? It of course it's horizontally scaled. It runs on top of Hadoop, and it is the most popular NoSQL system in Hadoop, right? So, and because it runs on top of Hadoop, you get the automatic partitioning, sharding, scaling. So Hadoop basically does that for you, right, with HBase instead of being separate. Okay. Again, just as a recap about columnar data stores, the one in your left is what we call a traditional database table, right? So the traditional database table here, you will have 3 columns. One is your key, right? Then, of course, you have information, in this case, height and state, right? So cutting is 9 feet and it's in California. ClipCon is 5 feet 7 inches and it's in California. But in order to store that in a columnar data store, you can't store it in this manner because you only have a key and a value, right? So here you can have multiple keys. In this case, you have a row key and a column key, and you have the value. So this is how you can, quote unquote, simulate a tabular data store in a columnar database. And the reason why this works is because you will always query the key first, then you query the value inside the key, which makes it efficient, right? So this is why you would use a columnar data store. Now, not every use case can benefit from columnar data stores, and that's why you have to watch out what use case you use. Okay, so in this particular case, you have the key, that's the initial query, then you get the column that you want to get the value from, right? Now, this works well for a lot of use cases. For example, preferences. So database preferences, like the Cassandra database use case for Apple Cloud preferences that's stored in a huge Cassandra database, for example. So that use case will also work on Hive. Okay. Now, HBase table is actually stored in HDFS as well, right? And it can be broken down into multiple regions, which are replicated across servers. So HBase has a concept called region server that runs on individual Hadoop nodes. So you can distribute HBase across a cluster, and it can store its data in those separate nodes as well, which basically allows you to scale out, right? Then, of course, you have this concept called column family. So you try to group columns together if they will be queried together. And of course, there's one store per column family per region, right? So region is a physical DMARC, and column family is data. So again, you can think of column family like a partition of sorts, okay? Then store files are the actual files where the HBase data is stored. Now, for the purposes of the class, we don't really have to know the physical structure of how the data is stored in HBase. But if you wanted to look at HBase files, you can actually look at the store files. They are actually the default is sequence file is the default storage format, for example. So this is what the HBase architecture will look like. You have your HMaster or your HBase master, which is loaded by default. It uses Zookeeper for quorum, so you can run multiple HMasters, for example, to keep to provide redundancy. So HMaster is like, it's considered like a name node, right? Then Zookeeper is your quorum, your quorum server. So client checks the Zookeeper. Zookeeper will assign you to any of the HMasters, right? And the HMaster will say, hey, for this particular query, talk to this region server. And if you are if you support replication, like you're running on multiple nodes, then it will give you multiple region servers for the same chunk of data. And you can query those region servers to get the information. So inside the region server, you have an HBase region, then you have a mem store for each kind. And inside you have your actual store file. It's actually stored as a .h file inside your file system. And all of this is stored in DFS. Of course, what typically happens is one H region server runs on a unique Hadoop node so that you still follow the principle of locality. Okay. Questions so far on architecture and storage type. So this is just the high level overview of architecture. And just to take note, only use cases that benefit from columnar data store will benefit from HBase, which is not all database use cases. Okay. These are just instructions on how to install HBase in Apache Hadoop. It can be installed again like Hadoop, can be installed in standalone, so the distributed and distributed mode. There are just some mysteries, right? So Hadoop doesn't play well with IPv6, so I suggest you disable it. You might want to remove IPv6 addresses from the host files as well. And of course, you have to be using Java 1.8. Make sure Hadoop is working, which is the instructions I gave a while ago, and make sure the paths are configured. You can download HBase here, and you can follow the instructions here. But for this class, we won't be using this because there is, because we really don't need to, and it's much harder to configure. So we will jump straight to using HBase in EMR. Questions so far? Right, so now we will go with HBase on EMR, right? So EMR, again, is Elastic MapReduce in AWS. So what happens when I power up HBase in EMR is I give instructions to EMR to power up certain nodes. And what happens is EMR is the one that configures the multiple nodes, and it will install both Hadoop and HBase on those nodes. And it will, depending on the number of nodes I want, it can give me multiple HBase region servers to provide the redundancy. Then the backing storage of HDFS in Hadoop in EMR is actually S3, right? So it doesn't store it directly on those, although you could, but you can actually use S3 as well. So you can use that as backing storage. But for class, we will just be using regular EC2 nodes that are provisioned for Hadoop, and we will run Hadoop there. Okay. So let's do this. So let's follow steps. All right, let me share my screen. Okay, there. So now it's all of my browser screen. So first thing you will do is basically create HBase cluster. So again, run Vocarium, start it. In this case, let me check if it's still running. Should be running. Then click on AWS here to run my AWS console. All right. So some of you had some issues because some nodes were running and it was eating up credit. So please make sure whenever you leave and for the day, make sure things are closed. So just as a recap, look at EC2, make sure there are no instances running. All right. So let's just have a look first before we proceed, right? So there should be no instances running, right? No placement groups, no load balancers, no IPs. Well, IPs are okay because they don't cost, but load balancers cost, storage costs, snapshots cost, volumes cost, and instance costs, right? Key pairs don't, security groups don't. So these are configuration items, right? So they're okay. But instances cost, so make sure there's none, right? None. No instances, no volumes, and no load balancers. I think there was one case, one of your classmates was wondering why his credits were going away and he wasn't running anything. There was no instances running, but there were load balancers running. So watch out for that. Okay, now back to regular programming. Let's go to EMR. Right, so let's load EMR. So here, let's create a new cluster, right? Of course, again, here, all of this must also not be running, right? That's also one thing. So let's create a new HBase cluster. HBase cluster. Yes, it's a cluster. So we don't do step execution this time around. Okay, let's wait for this to load. I want HBase, right? So you can select, if you notice, you have a choice to select Core Hadoop, HBase, Presto, or Spark. Now, Core Hadoop will just install Core Hadoop. So all of these four actually have Core Hadoop, but you have the option to just use HBase, just use Presto, or just use Spark. In HBase, in case you want to do the Apache Hadoop version, I suggest you use the old 1.x versions because they are easier to install than the 2 versions in case you want to do the on-prem one, right? Because there were some changes made in the latest version of the 2 that's trying to be too smart for your own good, right? So HBase, select HBase, okay. I think that's fine. The version numbers aren't very far away also. So at least we won't see any surprises. Okay, then let us here, it doesn't matter what size we pick. So I'll just pick the default size, but just make sure that they're cost. I will enable all auto termination, which is already a default setting. It's nice. So if I forget to turn it off, it will turn off after 1 hour. Now the key pair, proceed with the CSCI 273 key pair, which I already created before. Now, in case you don't remember how to do that, let's do that first instead. Let's create. So I'll create a new key pair for this example. Although my key pairs are still alive, you can go here to key pairs. Then I can create a new key pair. So this one is 8. Let's just call this HBase key. Okay. So I create HBase key. It will tell me to download the HBase key. See, right? Then I will go, oops. Let me share that screen. Now I go back to my machine. So this is my guest operating system. Let me go back to my host. So this is my main host operating system. I go to my download folder, look for the key. It's the key there. There you go. Right? So that's the key. Super secret key. I transfer that key. For those of you who are using Windows, you will be using the WinSCP. For those who are using Mac or Linux, this will be the command. Right, then, what is my IP address again? 921685610. 610. So I'm transferring the key there. Oops. Right. So now let's look at my system, and the key should be there. Of course, my CSCI key is still there, but I now have an HBase key. Okay. Questions on the keys? Now let us go back to creating our HBase cluster. Okay. So let's go back to EMR again. So just in case you forgot where your keys are or you misplaced, that PEM file must be there, because if that PEM file is not there, you can't use the key. So that's why I showed an example. But if you have an existing one, you don't have to create a new one. HBase cluster. So let's wait a bit until the drop down comes out. Okay, so default version is fine. Defaults here fine, and I select my new HBase key. So notice HBase key now appears here. All right, then everything else is default, and I create my cluster. Okay, again, this takes a while to create. So if you notice, it's starting, right? So in this case, it tells me what to say. It will install the Amazon distribution of Hadoop. So EMR version 5.35. It installs these applications. So we need both HBase and Hive for this particular exercise. So it's good they're both installed, right? And we just wait. Right? So in this case, you will see, right, and it uses HBase key. That's important, okay? If this is not set, you cannot remotely connect to this machine. So that's why it's important to have that running. So in this case, it's provisioning my two nodes here, right? So let's just walk through the rest while waiting for it to log in. Now, of course, you can log in remotely to this instance. So after this installs, you will be able to see some user interface details here. Of course, since the machines have not been provisioned yet, you don't see them yet, right? You will see this interface and you're now able to secure shell to this, like how you secure shell to your EC2 instance at the start of the class. Once you're logged in, you can run these HBase commands, right? So this is an example of what we call the HBase shell command, which is the command line command for HBase. Although this is not the most common way HBase is used. The most common way HBase is used, like MapReduce, is through a program. You have a you have a library that you load into your programming language of choice, and you call functions within the SDK. But this one allows us to test and manipulate HBase from a command line. Let me give an example here. So this is an example of a creating a particular table. So in this case, we create a table called customer, right? So in this case, the customer is the table and it has column keys. So the main key is customer and the column keys are address, CC short for credit card, and contact, right? So that we create here. Now, in this case, we can load this example here, loads an existing demo database. So this is the demo database in S3, right? We can actually have a look at this while waiting. So while waiting, let's see what it looks like. So WS3LS, right? So this is a test database. So you notice there's a snapshot folder. Let's see what's inside that. So it has a HBase database that's already configured. I mentioned to you the structure a while ago. So this looks like the contents of a single region server. In this case, there's a default data directory. And inside, see, name of the table is called customer. And these are two, for example, quote unquote, shards of data. See what's inside them. Then inside each shard, right, you will see your column keys. Right? And the column keys will have data of its own. Oops. Let's get it. So let's copy that file. Let's see what it looks like. Oh, it's quite large. So again, this is an HBase. This is an H file, an example of an H file. Of course, you don't have to do this in your machine. You can leave them at the EMR cluster, right? So those commands a while ago will show you how to run them on the EMR cluster. This one is just for us to appreciate the data structure, how it looks like. You notice it has the column, the key, master key, in this case, customer. Then inside you will see keys, then you will see column keys, and you will see the data inside each column key. Now, if you notice, the data is grouped by column key. That means if you make queries within data within the same column key, it will be very fast, right? Because they're all in one. In this case, they're all in one physical file. So that's one of the benefits of using the benefits of using a columnar database. Doing queries or operations within a column will be really, really fast. But doing them across columns will be really, really slow. Okay. So let's see. Why did it slow down? So downloading. Yeah, but I will delete this afterwards because I don't have a lot of space. So let's see what it looks like. So this one is a data block, right? Single block. So here you see column address, right? And the address actually has column keys. So address city, address state, address street, right? So they have address zip code. So it is even further or even deeper level of data, right? This one, by the way, I believe is a sequence file format. So it actually has the data in text that stays in text, but the rest of the file is in binary. That's why you see these non-printable characters on the screen because they are binary, right? So this type is a data block. Okay, so I will not waste space. Let's go back to our Hadoop cluster. There you go. Let's see, it should be done by now. No, it's not. Yeah, but again, we already have a node, although it's still bootstrapping, but we should be able. So I can copy. So this is my IP address here. Please take note of that. So I can actually log into it. Specify key. How do I specify a key? Mm-hmm. Identity file. Identity file. HBase. I don't actually remember username. What is the default username? Is Hadoop. This is how you do it. Default username is Hadoop. Right? It should not have to ask for you. Sorry. You're not seeing that. So sorry about that. Let me share console screen. Okay, so this is where my key file is. It doesn't have to be the VM. It actually can be your base OS itself. Specify the key file. Hadoop is the username and host name. So this allows me to remotely connect to that node. Right? You can also connect it directly from your Windows machine or your Linux or Mac machine. You don't have to be connecting through the VM actually for this. Okay, let's see. I mean, it's still not loaded, so it may take a while. It's taking too long, actually. Maybe I'm not allowed. Let's try it from my host operating system. See which loads faster. It's taking a while, though. Yes, I now remember. So security groups, I forgot to allow SSH, I think. think I forgot to allow SSH. Yep. So I have to add that. Add rule SSH. See rule. Any. So I added a rule. Notice that rule there. Oh, wait, sorry. Again, let's redo that. Let's redo that. Let me delete the rule first. Let me go back to EMR. So let's go back to the AWS console. So I have my HBase cluster here. What I forgot to do is to set permissions that allow me to remotely access this. So it's already running, right? All good here, but it's not my security group for the master node. So I need to be able to connect to the master node. So there are two security groups here, OB and O7. So I need to edit this one, OB, because I need to be able to log into the master node from wherever. Again, this is not very safe. So normally you'd like to restrict who can log into your machine. But in this case, we'll just do it for the exercise. And since we're going to turn off the machine later, it should be safe enough for this activity. So you notice there are some default rules that are set, but none of them allow you to SSH remotely. So edit inbound rule and add a new rule here. Add SSH, allow anybody, and save the rules. Even you guys can actually connect, but you don't have my key, so you won't be able to do that. But again, at least you should be able to see it. Okay, so I set that rule. So let us now check if I can remotely log in. So let me unshare and reshare my console. Right. So let's try it again. This should work now. There you go. So don't forget, again, permissions, which you did already as part of your SSH thing. Unprotected key file. Let's protect our key file. Okay. There you go. So now I'm inside EMR. So let's go through the next steps of the exercise. So you can follow with your copy of the slides. But me, I will just copy this. So let's copy it here. We have to replace this master DNS with the host name. Okay, in my case, the host name was this one, right? So I copy that, paste it here. There. Let's see if that does the trick. So what this does, so I'll explain the command while it's running. This one basically, let me hide my, there you go. This one basically, of course, runs as the HBase user. So sudo runs super user command, run as the HBase user, and run this using a regular shell, the command that's being run is actually HBase snapshot export minus D, meaning it's actually import, right? So it basically takes this export directory, which we were browsing a while ago, pick the customer snapshot, customer underscore snapshot. We know that because that's a given, and copy it into my. So this one, I replace the master DNS here with my master DNS, right? And I set two mappers so that it will be fast. Users HBase so that HBase can enter it, and set permissions to 700. So this one, effectively, for all its longevity, just says load the stuff that's here, name customer snapshot, and put it here. So now I run my HBase shell. All right. Oops. What was that? Oh, because I am not permitted to log. Well, anyway, let's see. So now I have my HBase shell. I can first, let me create customer address. This I should have done a while ago, but let's see if I can create it now. See, so I have now a table customer, describe the table. It should have 3 columns, right? Replication, so 3 columns. Customer, 3 columns, name, 1 address, 1 CC, and 1 contact. Now I will disable it first so that nobody can read and write it. Then I will load. So restore snapshot customer, oops, snapshot 1. That was the name of the snapshot I copied via command line to HDFS, and now it should be in the HBase folder in HDFS. Let's restore that. And I enable customer. Now, let's see. Right, still there. Describe. Describe customer. So still okay, right? But this time, notice there's stuff inside. Right? Before, it's defining the block size. So let's see what's inside my newly loaded customer. So get is a command that you could think of like a database select, right? So it's a select command. So let's say get. So let me copy an example, because this is not, it has to be very specific. So the customer IDs are not very user friendly, right? So Armstrong Zula, and I want to get only credit card type, right? So this means the value, oh, is American Express. What if I get the whole credit card? Pwede rin, right? Or I can get that entire key, right? So you notice this particular key, Armstrong Zula 8570365786, has actually 3 columns, right? And each of the 3 columns have further subcolumns. The address has 4 subcolumns, credit card has 3 subcolumns, and contact has phone, just 1 subcolumn. So if you want to query a subcolumn, you can put that here, right? And it will show you the subcolumn and all its subcolumn, or you can specify it. In this case, it's the same thing. However, for address, you have a lot more stuff. right? So you can show it all, or you can specify a subcolumn. Okay, so get is just a way to access the data. So again, imagine if this were a preferences database, then you can do that. Okay. Another way, another syntax is column. Right? So that's another way of specifying it. Notice it's kind of the same as this. Yeah. Although one of the things that you notice is this is much faster than this because I specified it as a column. So I didn't have to search that whether this is a column name or a subcolumn name. I know it's a column already. That's why it's faster. Okay. What else is another example here? Specific customer key. Now let's do searching. Searching is a bit strange here. So let's use the examples in the deck. So in this case, scan the customer table, and I say must start with Armstrong and ends with Arms H. Why? Because it actually includes, but not it is it's like an O open closure. So it doesn't include H. So everything before H, which is G, and everything after underscore is and any letter. Right. So this one is it will return to you all the Armstrongs, right? In this case. But if you want, say, all the arm, let's just say RZ, right? And well, there, I think there's only Armstrong. Say all starts with letter A. So here it includes Abbott and not just Armstrong, right? So searching is a bit cryptic using the command line interface. You just have to watch out, right? So let's look at credit card. So let's look at an example. Right. So there. So this is some credit card numbers as well. So if you want to get this user's Aliyah Abbott's credit card information, there's no credit card information. Let's see. Oh, Abbott Leah score. Oh, that's odd. Let's see. Maybe I'm spelling it wrong. Abbott underscore Ali. Let's see. Let's see. Aliyah 7. Yeah, it's odd. But pwede. Let's. And that's why scan is, because here this has to be very precise. While scan is looser. Let's put no limit. Oops. Let's remove the limit. There's a lot. Oops. Apparently Control C kills the shell also. Let's get customer. So that's why scan is better. Scan gives you more options here. Armstrong, Zula, 5, 7, it's odd. If we scan, comes out. Okay. So either way, you should be able to do some queries, but the interface is not very intuitive, right? So one of the ways to improve HBase is to use the Hive in the interface. So you can do that. First, let's close this. So you can do that by running the Hive interface. So makes it easier for us. Again, replace master DNS with your let's copy that here. So this one allows me to use a Hive interface instead of an HBase interface, right? But first, I have to create my external table because I have to tell Hive how it's going to process that. So let me just copy paste it before we go through all of that. Let me explain quickly. So this is what the table looks like. Okay. So first is create external table customer, and I make the row key, meaning the main row key for the customer table, row key, and I have string, street, city, state, zip, which are part of address, CC type, which is type, CC number, CC expire, and phone. So what I did is I just used the same structure in HBase, and I sequenced it and I made them columns. So I forced them. So I forced them to be columns. And of course, I used the HBase Serde, right? And I specify the column mapping here. So notice the column mapping here is key address is now street, right? So key is the main key, address street, address city, address state, address zip, followed by CC type, CC number. So I specified the sequence based on how I want it to be. So I can swap the sequence here. I just make sure to swap the sequence here. And contact phone, just the last one is phone. In HBase, and these are just default values, and the name of the HBase table is also customer. All right, and that's it. Now I can say describe. Oh, there's no describe, sorry. Select from customer. So this one just reads it like a normal SQL database. So the SQL semantics actually work here. Now, mental note, just don't forget to put a limit because this is, I think, 65,000 row database. So there's quite a lot. Okay. Your activity, your HBase activity, which is quite simple, is actually to use what you're seeing here and just run a few queries. So it shouldn't be very hard. Now, HBase being a tool is not really meant to be used as a database like this, but this one just makes it easier to browse the data. Okay. And of course, any other SQL command, right? SQL, you can limit it and filter with where, group by, order by. So anything that works in Hive works here as well, but the backing storage is HBase, and that's why the performance is better. You notice there's no MapReduce semantics, right? There's no, I had to provision mappers and reducers and all of that, and you had to wait for the results. The results effectively came out right away. Okay, so maybe I should interrupt this. Done. So nasa C pa ako. So let's see. I pressed Control Z, and so let's run Beeline again. So again, don't do that. So ours is from customer limit 5. There you go. Let me see. That took a long time. So let's see how many rows that is. Count. I'm not sure this will work. No, see, it does not work. So I think we should specify a column. Key, row key pala. Like asterisk row key. Okay. It runs an HBase job. Again, this is a full table scan, right? So it will take a while, but yeah, it should be. So this one counts the number of rows entire database has. Okay, while waiting for this, are there any questions so far? So again, this is how you do HBase in EMR. You notice it's running and we're accessing it as if it were a normal system. There would be 3.4 million rows. Okay, and that's it for HBase. Questions, clarifications, violent reactions? Quit. Paano nga ito mag-exit dito? Kalimutan ko na paano ma-exit sa Hive. Okay, questions? Wala? All right, so again, before you, I think Beeline is still running, that's why it doesn't allow me to log out. This is the Beeline I was saying. So to go back to a job that you control Z out of, you can press ano. Ayan, there. Oops. There you go. Control C is what I did. Right. Now I can log out. And I'm done. Questions? Okay, so let's stop sharing this and let's share the main window again. Share, share, share. Okay. So again, don't forget, this is done, right? So this is a running cluster. It's actually running. If you look at the main dashboard screen, you will see it waiting and cluster ready. So you can terminate the cluster once you're done, and it will start to shut down. At least to make sure you have no stuff running. Okay. And that's it for this session, right? So let's have a look on, again, instances. You will notice even the instances that you were running as part of the EMR are actually seen here. Look, there's 3 instances running here, right? And there are 9 volumes because that's part of the EMR. But once EMR completes shutting down, they should all be 0. Okay, so this is one place, right? EC2 is one place to check if your spending is still moving. Okay, right, and that's it for today. For your exercise, there will be HBase query due next week as well. I moved, by the way, the Hive's done. Here are some instructions on how to do HBase filtering, right? And you can do them either in a Beeline or in the HBase shell, right? So Beeline allows you to do it via Hive. It's make it easier. Okay. So just do this query, right? And show the results. If you do it in Beeline, you get full credit. Okay. Questions? That is it for today. And if there are no questions, thank you very much. And please tell the rest of your classmates that that we now have a Beadle in case you have questions. Tapos if you want to discuss, for example, if you want to have your own chat group, etc., I find that that is useful as well, because there are certain, for example, consultations done by some of your classmates that are relevant to you as well, right? I mean, you encounter the same problems. So instead of coming to me, sometimes I cannot reply right away. At least, some of your classmates have gone through it as well. Okay. So that's it for today. Thank you very much and have a good weekend. Bye.